Welcome to my channel. I'm Zhang Xu. Let's look at the problem 28 in chapter 27. Chapter 27 is about magnetism. So there we have an electron. This electron carry one unit negative charge, right? And then it enters a uniform magnetic field as B. And there, the V and B with angle 45 degrees determine the radius R and the D. This is the distance between loops of electrons helicopter passes. So now we can see, we know the velocity makes the angle 45 degrees, but its magnitude given us is 3 times 10 power 6 meter per second. Agree? And then in this vector, in this velocity, we can see we can project it in x component and y component. For x component, this Vx just makes the particles moves horizontally, right? And for y component, we can see it perpendicular to the B magnetic field density. This Vy makes the particles do circular motion. Agree? So we can consider this is two motions: x component moving forward, and the y component, this do circular motion, right? So we can project the V in the x component and the y component, so we get the Vx, Vy there. Now we can see, ask you to find the distance between loops. So the distance between loops, so this is in the horizontal. So we have Vx times t, right? And then this t is called period. Period is time for one complete cycle. So we can consider it as 2 pi r divided by Vy, right? And the next one, how can you find Vy? So Vy, you can see this is a central motion, right? This is a circular motion. So the central force EVyB equal to mass times Vy squared divided by r. So from there, we can see we are interested on r over Vy. So this one, from this equation, you can get r over Vy in this function. And you input it inside, you can get the period t as 2 pi m divided by EB. And then you input the t inside, you get it there, Vx as V times cosine 45 degrees. Input all the given quantities, you get the answer there. The next one determines the radius. This one is simple, right? You just from there, from this term, you can see you get R equal to M over EB times Vy. Vy as V times sine 45 degrees, input the quantities, you get the answer by yourself. Sorry, I didn't do this calculation on my slides. Thank you.